Guy Hurst has been a serious amateur astronomer for about 50 years now, and in that time, he's won the respect of amateur and professional astronomers all over the country. He was once the national president of the British Astronomical Society and founder member of the Basingstoke Astronomical Society, which I know personally has been highly successful and going strong for many, many years. Unfortunately, Guy has been suffering from Parkinson's disease over the past couple of years, so his enthusiasm has never dimmed, and he still has a role in supporting links between amateurs and professionals, as well as continue to edit the Astronomer magazine, which some of you will have heard of, which he has done so since 1975. So it is a special privilege for me to welcome you, Guy, to this interview for Humanistically Speaking magazine. Thank you very much for coming on board.
Thank you.
Now, to start, I imagine that astronomy, which has always fascinated me, but to me, I always think of it as the second oldest profession. Why do you think so many of us are absorbed with the heavens?
Well, I think when you go outside for the first time looking at the sky at night, you see an awful lot of objects which are an enormous distance away and which you can never reach. But the curiosity of how far away they are and what they're made of and what their temperature is something which you can read about after you had your observing. But all of that can be done with the naked eye. Despite the fact people assume that at times you need to buy a big telescope and spend a huge sum of money, you don't really need to. Binoculars are good, but naked eye does contribute a lot as well.
I guess we've all had that feeling. I certainly have, when you sit in the garden at night on a summer's night and you look at the sky, and it's astonishing what you can see. I've seen satellites by the naked eye just going across the sky. But I get the impression that, well, obviously your interest is lifelong. But when did your interest in astronomy begin? I mean, was there a sudden revelation that inspired you?
Yes.
Or have you always been interested naturally in astronomy? Or was there a person?
I've always been interested, but there was a time in early 1970 when Anne and I were traveling to get back to visit my mother-in-law, and we stopped in a lay-by in Lincolnshire, and I noticed an object moving across the sky, which in the early 70s is a satellite, but there weren't many of them around compared with now, where we're swamped with them. And I wrongly, with limited knowledge at that stage, thought if I went and bought a telescope when I got home, I might be able to see all the detail on the satellite. Well, that's a myth, because it still looks like a star in binoculars and a telescope. But it triggered me into wanting to do more, to investigate a bit about satellites and meteors and similar objects. But all that was part of a lay-by in the very dark era of Lincolnshire.
Yeah, that's amazing. I can remember one of those nights when I was sitting out in the garden, and I know I saw the International Space Station. But when I looked at it with the naked eye, it just looked like a star screaming across the sky. But when I looked through a pair of binoculars, just ordinary binoculars, I was able to make out the shape just about, and I know it was the ISS. So I think that was quite amazing. But that's quite low orbit, isn't it? It's quite nearby.
It is. I found, talking of binoculars that don't seem very powerful, that if you know where Jupiter is at a particular time, you can just about make out the moons of Jupiter with small binoculars. People are very surprised when I tell them that. It's a bit of a shock, really, because they're very far away, but they're also contain a lot of useful information, really, and all that with 10 by 50, so it's 10 magnification, 50mm lenses.
Well, Guy, this is your show, not mine, but I must tell you that I was once sitting under the stars with my current wife, and we were looking at the stars, and I looked at that star, and my wife said, "No, it's not a star, that's Jupiter." And I said, "How do you know it's Jupiter? It just looks like a star." And she actually had a telescope. She brought out the telescope, and I actually looked through the telescope, and I saw not just that it was Jupiter, but I saw 4 of its moons, 2 on either side. All on the same plane, which I thought was absolutely, it just blew my mind. just astounded me, absolutely astounded me.
The planets have an interesting part to play to somebody new to astronomy, because very often they think they've discovered a new star or something that's exploded. And the most common false alarm candidate is Mars. There's something about Mars which is deep red colour, which strays across from night to night, moving slowly, and gets into an area they're quite sure they've never seen anything there before. So Mars is my common false alarm I have to investigate, because I handle discovery claims from all over the world. And Mars is often cited as the possible candidate for an exploding star.
Just to be clear, there are no canals on Mars, are there?
No. I've tried looking myself with big telescopes and never seen any.
So, I mean, there are lots of exciting astronomical events going on, but what's for you has been the most exciting astronomical event that you've observed in your time?
Well, I think quite soon after I got involved in the early 70s, 1975, it happened that there was an genuinely exploding star in Cygnus, the constellation of Cygnus. And we had a telephone call middle of the day from somebody called Brian Marsden, who did run the Central Bureau for Astronomical Telegrams and dealt with the clearinghouse for discoveries. And he said he'd heard from Japan that they discovered a new object, or an exploding object, to the naked eye. And that very rarely happens. Nothing's usually that bright. But I went out and saw it for the first time within minutes of the announcement of the discovery, and it was middle of the afternoon. And it was a nightmare for the Brian Marsden, because he had tried to communicate, and it was a bank holiday weekend, and a lot of the systems, a bit like today to some extent, didn't work all that well. So we ended up having to ring quite a lot of people to alert them.
You say this is in the middle of the afternoon?
Yeah.
You see it in the middle of the afternoon?
Yeah. Admittedly, I've been given more details of where it is. I didn't find it by accident. But it's very rare that we see anything to the naked eye. You can just about make Venus out sometimes for the naked eye, but everything else is too faint.
That's extraordinary. Yeah, I've never heard of that before.
Yeah. But the interesting thing is, it generated over 50 phone calls to hear. Independently, people didn't realise when it got dark. They thought they were the first ones to see it.
As you would.
And one lady rang up in the middle of the night who was walking her dog in Wales. And she wasn't an astronomer, but she remembered the constellation of Cygnus, the actual patterns of the stars, had been disturbed, as she quoted it. The pattern was something different, but she wasn't quite sure what had happened. So she rang us and we explained it was a new exploding star that was too faint to have been seen before. She was fascinating. We had this interesting conversation about 2 a.m.
Ruin your sleep. Just moving on to slightly bigger things than stars. We did discuss briefly about the universe. I mean, are you a proponent of the Big Bang or steady state or some other mechanism that actually sustains the universe?
Well, although it's only a theory, I do support the Big Bang. I know it happened 13 billion years ago. But the interesting reason that I perhaps am more supportive of it is that a lot of what I study involves exploding stars, a speciality. One category of which is supernovae. And it's they which have given us lots of clues to the Big Bang and how long ago it happened and how far away it was and so on. So part of my interest overlaps with the Big Bang, but it's only still a theory, isn't it? We're relying on James Webb perhaps to find out more for us about that.
Yeah, I'll come to James Webb later, but just to be clear, when we talk about the Big Bang, that doesn't necessarily mean that you're favouring the Big Crunch. You're not suggesting, or are you suggesting?
No, not necessarily. I mean, I'm just interested in the events that led immediately after the Big Bang.
Yeah.
Stars being late in being formed, galaxies coming quite late on. So we are piecing it together. It's like a giant jigsaw puzzle to me, but some progress has been made.
I think progress has been exceptional over the last 20 years, hasn't it?
Yeah, definitely. Yeah.
Now, I can understand how we can calculate the distance of the planets. You know, I can understand methods of triangulation and possibly other methods, but this is far too crude to ascertain the distance of the more distant stars and even galaxies. So how is this done? I mean, I've seen things in writing, and astronomers say, oh, well, this particular galaxy is 5 million light years away. Parallax won't help you work that out. I mean, how do you do that? How do you work it out?
Well, a lot of astronomy is although we look at as amateurs at it visually or with a telescope, most of the astronomy is done with using the analysis of the spectrum of stars. And it was known that there were lines in the sun's spectrum which represented the elements, hydrogen, helium, and so on. But the interesting thing about the stars is after they got a method of studying the spectrum, they found those lines were not in the same position as they were in the sun spectrum. And there was a relationship between how much they shifted out of the sun's position and the distance that object was away from us. We call that the red shift.
Does that indicate the speed that the stars are receding from us? Because the Big Bang's still going on, isn't it? It's still splashing out.
Yes,
it's going faster and faster.
The more the lines are shifted to the red part of the spectrum, the more further away it is, but also faster it's moving away as well, which suggests that there was an explosion and it's still having an effect, and you still find objects taking distance away. But the thing that often is overlooked is that you can have a blue shift, which means it's coming towards you. There aren't so many of those. And the interesting thing is the Andromeda galaxy, which is slightly bigger than our own star system, is one of the objects that's blue shifted to come towards us, but it'll be millions of years' time, so no cause for panic.
But what happens when galaxies collide? I mean, you don't have impacts of stars coming onto the Earth, do you? It's quite possible for galaxies to collide and not actually to touch, isn't it?
That's right. I mean, they're often described as a massive explosion that will take place. In fact, it's possible for two galaxies to have their individual stars passing through each other without a collision at all. But in the end, if they get very closely lined up with each other, they can merge into one super galaxy, much bigger. Andromeda has already absorbed some of its companions, small companions, and now is bigger than we are at the moment.
Extraordinary.
But blue shift is around, but red shift is crucial to discovery of the distances and the speed of expansion.
So if you get a blue shift, can you similarly calculate the speed or the distance of the star that's coming towards you?
Yeah, this is in reverse, really, effectively.
Yeah.
But the interesting thing about going back to supernovae I just mentioned is that you can use the spectrum of supernovae to more accurately measure the distances than just ordinary redshift of the spectrum. And these supernovae, surprisingly, are often because of a massive explosion. But there is a degree of consistency about the type of explosion and the physical effects it has. So they call that the standard candle. It means that despite the fact you imagine the explosions would be the last thing you regard as standard, the actual brightness that we see them, just looking at what we call the magnitude, the degree of brightness, tells us, if we assume that the explosions are standard, that any change in brightness is real distance change from the first one you look at to the second one.
Well, I didn't know that. So a normal, let's say a regular supernova, would have a kind of standard brightness that you can actually measure. And if it's a long way away, it's going to be dimmer, and if it's nearby, it's going to be brighter. Is that what you're saying? That we can,
Well,
it's a kind of standard brightness that comes from
yeah, just to clarify this, there's a certain type of supernova. It's actually two stars, one of which we call a white dwarf, and it's stealing material from its companion. But the standard explosion effect is that scientists have found that there is a certain amount of material that it's gathered from its companion, stolen almost.
Mm-hmm.
But when it reaches a certain level, it explodes. The system can't cope with the extra material that is taken on. But that happens consistently across a certain type of supernova. So any brightness you see between one supernova and another that looks different and can be measured just by ordinary photography, really, is accounted for not by the explosion itself, but by the distance between us and the first supernova and the second. We call that the standard candle effect. And that's what I've been studying myself with supernovae. I actually image them and regularly measure their brightness. And I can feed that back to the professional astronomers. So pro-am, as we like to call it, the cooperation between the two sides works really well.
Because you're a link man, aren't you, between the two, between the amateurs and professionals?
Yes.
But since you talk about supernovas, perhaps now is the time to ask you what is the difference, say, between a first-generation star and a second-generation star? Astronomers often refer to them as first or second generation, don't they?
Yes, you're quite right. Well, the first generation are the earliest stars that were formed soon after the Big Bang, and usually most of them were much more massive than most stars today. We've got some still that are big, but not in such great proportion, whereas to start with, it's thought that most were giant stars, and they often say they had a shorter lifetime than the smaller stars. Mind you, they're talking of millions of years ago in distance, which is what astronomers always have trouble saying. They sound as though they're talking about trifle amounts of things in all the television programs we have, but to somebody who doesn't know much about astronomy, when you're suddenly told, we mean millions of years, they have to try and adjust the comparison between one thing and another, which is quite difficult. Yes,
I mean, a star that has a life of 50 million years is a short life, isn't it?
That's right.
Our sun's been around for thousands of millions of years.
So going back to the first generation, the second generation, the first generation, after they'd gone through using up their fuel, which was largely just hydrogen and helium, what we call a pure spectrum, really. It doesn't have all the other elements at that stage. When it explodes, that material is blasted in all directions into space, but eventually comes back to form smaller stars, including our sun as a generation 2 star. So it's a case of massively clever recycling.
Yeah, I mean, you'll correct me if I'm mistaken. I thought a first generation star built up the elements up to iron, which is very, very stable.
Yeah.
But it would take a nova or a supernova to go beyond iron into kind of gold and silver and those sorts of elements. And it's the second generation stars that actually contain the elements of gold and silver.
That's right. Yes, all the extras. Yes, that's right. I mean, going back to iron in the first generation, it can't develop further down the scale of elements.
Mm-hmm.
Just gives way, so effectively explodes and expands out. But all that material is going to be reused eventually. One of them, a bit of material from several giant stars could have helped to form our sun. But we're second generation, to answer your question.
Do you know, your answer is triggering off so many questions in my mind. It's getting a bit confusing in here. But yeah, it's absolutely fascinating. It's an issue that I'm particularly interested in myself. But you haven't mentioned anything about manned space travel as distinct from, I don't know, robotic space travel. Do you think, what sort of future do you think manned space travel has? Do you think it's going to really be an effective means of occupation of say the solar system, or do you think it's going to be impossible in the end to meet the human physical needs that space travel may not provide? What do you think? Do you think there's a future for manned space travel?
I think so. Certainly extending our original exploration of the moon. Surely we should follow that through again. I mean, there have been all sorts of theories about collecting pure energy from the sun on one of the moon's special machines. I don't know what we call it, but collecting energy basically and redirecting it by a laser effect to Earth, making energy conservation.
What about Mars? Do you think? I mean, I hope I live one day long enough to see a man or a woman walking on the surface of Mars. I'm beginning to have my doubts about that now. But do you think there's a future of that further distant travel?
I think the moon is quite a simple one to cope with compared with Mars. Mars has got lots of films recently about Mars saying you just land and you grow some plants and you generate oxygen. Make it sound like
it's a good film too.
Good film, but it's probably oversimplified how difficult it is. Mars has lots of storms and weather conditions. I mean, it's thought that Mars originally was very much like the Earth, but has gradually lost most of its atmosphere, for one thing. So there's a lot of big risks involved with Mars. We've already proved, despite the fact that it seems a long time ago now, that we visited the moon and managed to cope with walking on it and so on. But Mars is a much more difficult proposition, I think.
Mm.
But I think even if the moon could be developed with a lunar station and energy redirection to Earth, there must be more things that could be done. There may be other things, there may be medical issues that could be explored in vacuum and so on. It's a pity we gave it up so long ago, really. It's almost a shame that it's been
Well, that's how I felt. I remember the excitement in 1969 when the first people walked on the moon, and we thought that was the beginning of a new era.
Yeah.
And the sad thing, I think, is that since then, a lot of the technological knowledge that was known at that time, that had been learned, hard learned, had been forgotten.
Yeah.
And had to be relearned, rediscovered, which makes it a bit of a waste. More a kind of optimistic step into the future rather than any serious approach. Hopefully, the more serious approaches will come this time. We won't go backwards again.
To put a landmark for me, 1969, because it was the time they were landing on the moon for the first time. Anne and I got married that year, so I can well remember the date.
Yeah, you don't forget dates like that.
Yeah.
Anyway, if I can move on again slightly, the current excitement seems to be with the James Webb Telescope. And to be sure, there's no question it's a technological marvel. But at the cost of $10,000 million and the involvement of no less than 20 participating countries, why is it so important? Why?
Well, there's such a keen cooperation between countries, and it fascinates me that we are worried about possible wars and the effect of violence and so on between countries, and yet when it comes to science, especially astronomy, it's an excellent method of bringing all countries together. And I think the European Space Agency, which is the one that Brittain signed up for, I think Mr. Blair signed a bit of paper, if I remember rightly.
Mm-hmm.
Basically, they've been cooperating for years and years. And it's very healthy, isn't it, to have countries working on science as joint projects?
There's a lot to be said for that. The European Space Agency, are we still signatories to that post-Brexit?
Yeah, we are.
Right.
So there's NASA and there's the European Space Agency, and they often work together on joint projects as well. So I think it's very healthy, but it's not easy to defend, as you correctly raise, vast sums of money being spent. But there have been spin-off benefits to both our knowledge and medical research and so on from studying together joint projects of astronomy.
Yeah, I mean, personally, I don't think we should limit ourselves to prosaic sort of day-to-day inventions and discoveries that it brings out, because I think exploration is part of the human condition. I really do, and I think it's what we are.
There is an easy way with Mars of using rovers and now drones to study and fly over different points on the surface.
That's remarkable.
They've been so successful in the tests with the drones that they'd already talking about trying to land a drone on a place called Titan, which is the largest moon of Saturn. They went there once before, many years ago, with a spacecraft landing, unmanned. But now they're talking about drones that can land hop across from one side of the surface to another.
I think what struck me as most remarkable about the drone on Mars is the fact that, you know, you have to, the atmosphere there, as you said yourself, is very, very thin. And any flying machine has to rely on lift in the atmosphere.
Yeah.
And that must have been very cleverly calculated. I've no idea how they did that, but the drone itself has been very, very successful, hasn't it?
Been very successful, yeah.
Just to come back to the James Webb Telescope again, I mean, if everything goes to plan, and so far as I know it has been, this telescope should see the furthest reaches of the universe, and we'll be able to look back in time by thousands of millions of years. I mean, I get that. But what are we likely to learn by seeing stars being formed by then? I mean, stars are being formed all the time, even now.
Well, rather surprisingly, not as many as you might imagine. I looked up with regard to our own galaxy, which is a big area of sky we call the Milky Way.
Yep.
On average, they say that the number of stars born each year in the Milky Way galaxy is 1.
Just one?
Just one. That's approximate. I mean, I'm not saying it's never going to be 2 or we're going to have a year without one. But there are not so many. It takes a long time for the process to be triggered. All the material from the earlier stars is being recycled, but it doesn't happen suddenly. So if you take the whole universe, then you're talking of billions of stars because there's just so many galaxies. But just taking our local galaxy, average of 1, which is a big surprise, isn't it?
Yes, it is. I must say I am surprised about that. But even so, if you're looking, you know, have you got any idea what we might be learning that's new from looking at the stars being formed right at the beginning of the universe? I mean, would they be formed any differently? I mean, perhaps it's an unfair question because, you know, we're using an instrument to see, to learn what we can find out. So we don't know what the answers are. But I mean, do you think NASA has any clear idea about what they're looking for at the end of the universe, as it were?
Well, I think the actual study of all these objects has been a handicap because when we first started, we had spacecraft in orbit around this Earth, suffering light pollution from our atmosphere, and now even light pollution from ourselves. But gradually we've parked things at more distant places like Lagrange 2 for the Webb telescope.
What is a Lagrange?
Shielded it from pollution from the sun being too bright by building sun shields.
Yeah.
Gold covered multiple mirrors that are welded together into a giant one. So we're going to look much further back, aren't we? And we don't know whether stars were formed in quite the same way then because we've not been able to study them. The lifetime of first generation, as you raised in the first place, is so short, relatively speaking, that it's quite difficult to look far enough back to see how the formation went for the first generation.
Because by and large, when we talk about the short life of stars, the larger the star, the hotter the burn, the shorter the life. Right?
Yeah, that's right.
Yeah.
Yeah.
You mentioned the Lagrange point. Is that how you pronounce it? The Lagrange.
That's the way I use it.
Yeah. I mean, it's a point in space where the James Webb Telescope, is it where it will always appear in the same position relative to our Earth, or what does the Lagrange point actually mean?
Well, if you take the discovery on Jupiter, which is our biggest planet in the solar system, has a lot of asteroids in orbit around it. And the curiosity is that they never collide with each other. It's as though you've got the motorway, if you think of M1 and the traffic, you're always worried that they're going to come too close together because they're going so fast. But the combined effect of Jupiter's gravitation on these asteroids and that of the Sun and the Earth and all the other planets arrives at a position where they're parked in a place in clusters where they don't ever catch up with each other or fall behind. They don't collide, and they were the first indication of Lagrange points. It's where the rest of the solar system is helping you park something somewhere where you don't even need extra fuel to keep adjusting where it is. It stays in place. And once they realized that Lagrange could be used for spacecraft, not just nature's asteroids, then it's an ideal position, isn't it, to put something somewhere where you haven't got to keep fueling it to control where, otherwise it would drift off and be lost to space.
Well, I think that's quite extraordinary that someone would think of that.
It's wonderful nature supplies us with ready-made solutions to things.
It is. It is.
Yeah.
It is. How many Lagrange points are there? Do we have any idea?
Well, normally, for Earth, there's 5. And James Webb is at Lagrange 2. But they've just made a discovery in the last few days of another one, not a spacecraft, but a natural object in Lagrange 4. So it's not they're huge numbers, but they're being influenced by solar system, planets, and Sun and Earth to control where they stay. And Earth has only got one, up until a few days ago, literally, Earth had only got one object parked permanently by nature, effectively. And now they've got 2, of course, with the James Webb reaching its destination.
So, yeah, that's and of course the James Webb Telescope is 1 million miles out away from the Earth in orbit. I think it must be one of the furthest man-made objects in orbit around the Earth, because it's 4 times as far away as the Moon.
That's right.
But can you see the James Webb Telescope through a telescope on Earth, an ordinary terrestrial telescope?
Well, my own magazine, The Astronomer, has got some pretty advanced amateur astronomers working, and they photographed it. There's half a dozen people have sent in pictures they've taken as it pursued its orbit all the way out to the new parking place. And they've been doing that up until a few days ago. So I was surprised that they did it as easily as they did, but we've got pictures showing the trailed image of the stars are being tracked, but the object is producing a trail because it's moving. Well, it was until it finally reached its destination. So we have done it. Yeah. Whenever this sort of thing happens and people say to us, that'll be very difficult for amateur astronomers, they always seem to come up with a way of succeeding.
Good luck to them as well. That's great. Since you mentioned your magazine, The Astronomer, it's rude of me, I should have mentioned this before. If anyone who's listening to this recording wants to get their hands on a copy of The Astronomer, what should they do? Is it an online magazine? It's
produced online, colour PDF format, but we also still produce it in paper form as it was originally launched in 1964. We found when we went to PDF and electronic and colour, we thought that most people would give up on paper, but it does seem a lot of people, as with books, quite like to retain the paper versions of some publications, putting them on the shelf in the study. I'm pointing at my study now.
So presumably people would buy that. They would pay for that, would they?
There's a subscription each year.
Yeah.
Costs £11 for a magazine monthly.
So,
but we also issue circulars because we realise that paper publications are not fast enough for astronomer. When the discovery is made, say a discovery is now being made at this very moment, which could easily happen. The fastest that we can get it to the amateur astronomers' readership, more pictures can be taken, more measurements can be made. And so we issue circulars announcing discoveries as well, or about 100 a year.
Well, that's yeah, so it's keeping them up to date. I think that's brilliant.
Yeah,
so, but what should someone do if they're interested in seeking the magazine? Should they just key in Google the Astronomer and find the magazine?
I should find us.
Okay.
I'm sure if they contact you as well, you can redirect them.
Naturally, we'll tell them. We'll pass them on.
Yeah.
Okay. Now, you're doing work yourself from the Robotic Observatory in Tenerife, and I know you're quite excited with that. You're quite engaged with that. Would you like to describe your project, the project that you're doing to us?
Well, for a long time, there'd been a project called Bradford Robotic Telescope run by the Bradford University, and it gradually was wearing out. And the Open University itself decided to make an offer to buy the Bradford Telescope. And the idea of robotic telescopes is that you park them somewhere on another place, like in this case, Tenerife.
Mm-hmm.
And they're not manned, nobody's there. The only way a repair could be done normally would be to fly somebody out there, which is not always convenient every 5 minutes.
Yes.
But the Bradford Telescope was wearing out, and Open University probably slightly regretted making an offer for it. But they decided they would buy a telescope, or two telescopes, one for the students who are studying at the Open University, and the other to support amateur astronomers with a telescope in a really favourable position from a weather point of view, such as the top of a mountain, and hence where Tenerife comes in.
Mm-hmm.
And recently they've moved it from being a 14-inch telescope, that is the size of the diameter of the mirrors, to a 17-inch and a much higher quality scope, which they allow me to use. So by the internet from my study where I am now, and I have been doing this morning, I can log in, download the pictures which may have been taken earlier in the night, and measure them with software that Open University have provided for me. And that's of sufficient quality that it's valuable to professional astronomers. So that's what my main objective, really.
So can you direct the telescope to your coordinates?
Yes, that's right. I have to feed in what we call the right ascension and declination. It's a bit like longitude and latitude on Earth. Yeah. We call it differently, that's all.
Yeah.
And that has to be quite accurate because the field of view of the 17-inch, although very powerful to get faint things, isn't enormous. It isn't a wide angle like binoculars. It's a very small area. So you've got to be very accurate. But these days there are catalogues online of positions if you're not sure what figures to feed in. Mm. But they've recently improved it still further. They've programmed in a lot of the catalogues, so you can now type the name of an object if it's well known. And the computer on board the telescope in Tenerife converts it to the positions and coordinates. And from that, you only have to decide the exposure time because you want to go as faint as possible, but you don't want to overdo it. We had a case where there was an exploding star the other day that was so bright it would have saturated a picture and destroyed it.
Really?
So we typically 1 minute exposure time for those of you who are interested in photography is enough, really. 1 minute. Can be up to 3 minutes.
I was quite surprised, and I paid a visit to an observatory in Uxbridge, and the person who was showing us around said, why don't you choose, said to me, why don't you choose a celestial object that you'd like to see?
Yeah.
And I just threw in the Andromeda Galaxy. And I thought that would be a problem for him, but all he did was just press a few buttons, and the whole unit just zoomed up, and there I was looking at the Andromeda Galaxy. I think it took about 10 seconds to actually find it.
Well, I've extended the project from just photography and measuring with the software, which is still pretty professional, is to try another experiment. I heard a lecture from a professional studying supernovae that the color of the object you're photographing, and if it changes, why it changes, is quite important to the professionals to research. So what happens now is the telescope in Tenerife has got 17 individual color filters. And so if the explosion is taking place and the temperature and the color is changing at that particular time, you can take more than one picture. You can take a blue filter picture, a red filter picture, and so on, and build up a story of possible temperature changes and explosions for the professionals to investigate further. So that's a new development, really.
No, I think that's fascinating. What's also fascinating is the idea of the 17 different colours. I didn't quite realise I heard as many as that, but we won't go there. I'm sure that different shades and all the rest of it. So we're coming to the end of this interview now. I could go on all day, to be honest, but I've got to ask you this. I mean, what do you think are the chances that there is intelligent life elsewhere? I mean, we do talk about the Drake equation, and for those who have not heard of it, it's an equation which a chap named Frank Drake came up with in the 1970s, where you could make some calculation of the likelihood of intelligent life elsewhere. And in the 1970s, I think there was about 10 points in this calculation. Nobody knew what those what the elements of that calculation was. We didn't know how many Earth-like worlds there were in the galaxy. We had no idea, or where the Goldilocks zone was, what was in the Goldilocks zone. But gradually, those elements of the equation are gradually being filled in, and as time's gone on, I've noticed that it's something coming into focus. So we're beginning to be able possibly to calculate the possibility of whether there's intelligent life elsewhere. So, but we're still in the area of personal opinions. I mean, what do you think? What do you think of the options, the possibilities of life elsewhere?
Volume of stars seems to me, without direct evidence of another Earth-like planet, is that we will eventually find Earth-like ones. In fact, by coincidence, only a matter of a few days ago, they announced the third planet around a star called Proxima Centauri, which is the known closest star to us apart from our own sun, of course.
Is this this is not a white dwarf, is it?
The actual star?
Yeah.
It's a dwarf star. I'm not sure, it's not a red dwarf, actually, but I'm going from memory. But the only thing is, from the Drake investigation, we believe that running water was one of the primary requirements to give a chance of life. They now think that's oversimplifying matters, because the dwarf has got explosions and can be quite destructive to planets nearby. So we're going back to Drake and we're reanalyzing those roughly 10 criteria: wind speed, the way the atmosphere's elements are made up. All that's got to be collated to give us a chance of knowing whether there's a candidate nearby. But in the sheer volume of stars in the universe, I'm personally of the opinion that it's highly likely we'll find certainly candidates. As you said, the Goldilocks zone is just one step towards that.
I think the key really is how long intelligent life can survive on a planet, which is a philosophical question as well as a scientific one, because the human species have only been on the Earth technologically for the last couple of hundred years. If this is typical of other planets, if they only last for 200 or 300 years, or even 500 years, the likelihood is very low that there'll be other intelligent life elsewhere. But if intelligent life can last for thousands of years, then obviously the likelihood goes up. So
if there are millions of stars, then it seems highly likely that some of them will be a similar size to the Earth. I was giving a lecture down in the south of England not long ago when they announced that they discovered a new star quite a long distance away and had 8 planets. The reason that excited them was that's roughly where we are now. Some stars, we've only found 1 planet so far, but this was an object with 8 planets. And interestingly enough, they were all of a similar mass and size to our own planet, Earth.
oh, really?
So that's the one that's being studied quite a lot now too.
Because in this,
one of the 8 has got life. That's a big find.
yeah, I mean, I think Jupiter is very significant, isn't it? Because Jupiter's been like an umbrella in a way, in keeping asteroids at bay, away from constant bombardment of the Earth. If you've got another solar system like that, with a Jovian planet, that's
They tend to think of Jupiter as a vacuum cleaner.
Yeah,
Yeah.
Maybe a vacuum cleaner is probably better than better analogy than an umbrella. Yeah.
Yeah.
Okay. Well, look, I'm just to close off. I mean, is there a book about astronomy that you'd like to recommend to would-be amateurs who are about to start out?
Well, I've got on my shelf one called Stars and Galaxies, which is also subtitled Astronomy Today, is an example.
Right.
I could get details of it through to anybody who contacts me or contacts you, and you get referred to me.
Yeah. Anyone who's listening to this interview.
That's the vital thing probably at the start is first to start using with binoculars, nothing too complicated for observing, and also to buy or subscribe to monthly magazines. And there are 2 magazines out of several that I would recommend. One is Astronomy Today, which is a British magazine, and the other is just called Astronomy, which is American counterpart. And they're in the risk of advertising on your broadcast.
Don't worry, we're not the BBC.
W.H. Smith have got both.
Right.
So Astronomy or Astronomy Today. Astronomy Now, sorry, I beg your pardon, I got that wrong.
Astronomy or Astronomy Now. And Astronomy Now is the British version,
That's
and
right.
Just Astronomy is the American one.
And they're both very good.
Okay.
But otherwise, you'll end up buying a book, whatever the book is. You're trying to sort of jump in quite a long way down the track. Those magazines have been written specifically to help people beginning and getting involved for the first time.
Right. I might actually get that myself then. Thank
Yeah.
you. So what would you say to someone who has been inspired by this interview and who wants to take it up more seriously? What advice would you give them to help them start off? You've actually mentioned the magazines, possible books. Would you say just get yourself a pair of binoculars and just look at the stars? What would you do?
But in addition, what I would recommend strongly is to join a local society, because people are only too willing, almost falling over themselves to help beginners coming into the subject. And the societies do a fantastic job. The way you find out whether you've got a local society is to contact the British Astronomical Association, which, as you said, I was president of. And that's on the web. Tell them where you live, and they'll recommend where the nearest society is and the contact details. Because there's so many people willing to help you, and you can ask what you think are silly questions, but they don't mind. They're always willing to come up with help.
Oh, I'm a master of silly questions, so I'm happy about that. And I think anyone, and also I'd ask you, Guy, if somebody writes into us and wants to ask you a question, do you mind if I pass those questions on to you?
Perfectly okay.
That'd be great. Thank you very much. It's been a real pleasure, and I don't think the Parkinson's has affected you at all. So well done for that.
Reassuring. I saw my consultant yesterday, and I told him what I was doing. He said, "That sounds quite ambitious."
Well,
You,
you.
I like new challenges.
Well, it's surprising what you can do when you're enthusiastic about what you're doing. That's the thing. But Guy, it's been a real pleasure, and thank you so much. I've learned a lot from you today, and I'll probably send you some more messages from myself. I'll ask you some more questions later on. But in the meantime, everyone, I'd just like to mention again, Guy's magazine, the Astronomer magazine, and if you Google that, you'll find that, and you'll be able to make contact with Guy directly. If you have any questions to pass on to Guy, do send them to us and we'll pass them on to him. That's it. Thank you very much. Thank you.
Humanistically Speaking is a volunteer-run online publication slotting in the gap between National Humanist glossy magazines and Humanist UK's newsletter. We aim to create a platform that can bring humanist groups and individual humanists together, of course, but also to allow non-humanists to join in the debate. We want to explore topics of interest that any freethinker will be concerned about and offer informative, factual articles that encourage people to reflect upon, explore, question, and share ideas. We are in an exciting marketplace of ideas, and it is important that humanists from all stables of opinion have a voice. Humanistically Speaking is unique in offering this. Our remit is constantly developing, and by the start of our second year, we grew from a bi-monthly to a regular monthly issue. We've also expanded from email communication only to launching our own website and created our first values publication, From Atheism to Humanism. All of this has been made possible through your donations and your goodwill, and we're deeply grateful to those supporters among you who have donated already. But this is just the beginning. Our aim is a bold one. In addition to offering our support to National Secular Society and Humanists UK's campaign objectives, we want to share the humanist idea with everyone in society. Naturally, we want to celebrate rational thinking, open inquiry, compassion, fairness and justice, but we want to balance these good things with enjoyment and having fun, a sense of comradeship, and the thrill of just being alive. But to go further, we need financial security, and we're asking you to help us. If you approve of what we're doing, please join us on our journey towards the foundation of a national humanist magazine that lends voice to every rational and respectful opinion. We want to explain and celebrate what humanism is and share humanist ideas that we believe can do so much to improve the way we all live. You can help us to achieve these aims by setting up a standing order of £4 a month or whatever you can afford to Humanistically Speaking, or if you're not able to do that, think about giving us a kickstart boost by donating a one-off lump sum of perhaps £20. Our bank details are at the bottom of this screen, but if you prefer, please click on the link below that will take you straight to the appropriate place on our Humanistically Speaking website and follow the guidance given. Every donation will be acknowledged with a message of thanks from us. One last thing before you go, do spread the word with your friends, because Humanistically Speaking is there for everyone. There are also many potential humanists out there who already share our values and yet don't know we exist. There are also humanists who don't have a group nearby and who might be feeling like a lone voice in their communities. We would like to serve them also and play our part in breaking down any sense of isolation. We're doing all we can by committing our time and energy. Please help us with your goodwill and donations and join us on this journey. Thank you.